Hello, guys. It's Mrs.Z, and we have a problem set on grade 5, mission 6, lessons 20. Problem set. Question number 1. Let's see what they would like us to do. The line graph below tracks the total tomato production for one tomato plant. So only one plant, how many tomatoes will give us? The total tomato production is plotted at the end of each 8 weeks. Use the information in the graph to answer the question that follow. So when we look, this is the graph, and the first we notice these are weeks. So approximately the tomato was growing 6 weeks and then start producing. So 1 week, 2 weeks, 3 weeks, 4, 5, 6, 7, 8. 8 weeks was producing tomatoes. So, and then the vertical line is tomato producing in pounds. So pounds LB. So when we look the graph, this is our X and this is our Y axis. This is our title of graph, total tomato production. So these are all information that should be looking into. So we know now that if this is 0, so let's see how the increment goes. 1, 2, 3, 4, 5. That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then this is week 6, week 7. So now we can look how much tomato, how many pounds from one to another were produced. So at first week it was we start with 1.5 pound. So right here it was 1.5 pound. Okay, so we can even label 1.5 if I do that. Okay, and then you can see that it grows till 3, so it goes 1.5. So now it's here is 3 pounds LB. Okay, LB is pounds. Okay, now from 3 pounds, we can see that it grows to week 8. It grows only 0.5 pound. It's about 3.5. So 3.5 right here. So it's 3.5 pounds. Then from week 8 to week 9, it grows from 3.5. It grew to 5 pounds. Okay, so it's like 1.5 pound more than it was in week 8. Then when we go to week 10, we can look here. It's in between 8 and 9, so 8.5. So 8.5 pounds. Okay, then it grew only 0.5 pound more in week 11. So this one here is 9 pounds. We'll put that 9 on the top. And then again, it was 9. So it stayed stable from week 11 to week 12. And the last week 13, what they measure, it was 10 pounds. Okay, 10 pounds. So now we just have, we kind of look over our data, see what kind of questions they have for us. Okay. How many pounds of tomato did this plant produce at the end of 13 weeks? How many pounds did they at the end of the week? So we need to calculate how many pounds is that. So so first week was 1.5. I'm gonna use the here 1.5. I'm going to draw a line through it. It's easier for me to. Okay. Then it was week 2 was 3. Okay. Week 8 was 3.5. Week 9 was 5 pounds. Week 10, 8.5. 11, 9. And again 9. And then 10. Okay, 10. All right. So now I can see how easier I can figure it out. This I can make tens. So 5 and 5 makes 10. And then 5 more, that will be 15. So 5 and 5 makes 10. 10 plus 5 is 15. So here's 5 and 1 more 10. Okay. Now, if I want it, I can also look for tens here. So I already have 1 10. Okay. Then I have 9 and 1. That's another 10. I have 2 tens. Then this one and this one is 1 more 10. That's 3 tens so far. So 3 tens is 30. And then I can do 8. This is 8, but 5 and 3 is 8. So double 8 is 16. So with 3 tens, that will be 46. And then I have 3 more, 46, 47, 48, 49. So it should be 49.5 pounds of tomato total. If I am not wrong in my calculation. So here is it. How many pounds tomato did plant produce at the end of 13 weeks? At the end of 13 weeks. The plant produced about 49.5 pounds. We can round that to 50 pounds, about 50 pounds. 50 pounds. All right. So at the end of 13 weeks, that was the question. When we add all from the week, how many pounds the plant. So now, how many pounds of tomato did plant produce? How many pounds of tomato did plant produce from week 7 to week 11? Week 7 to week 11. To week 11, so not included week 11. I would say that from week 2 the 7. So we should count the 7, 8, 9, and 10. So 7 was 3 pounds plus 8 was 3.5 plus 9 was 5 pounds and 10 was 8.5 pounds. Sorry, because how much I could understand how many pounds of tomato the plant produced from week 7 to week 11. So 2, to me, it's not included the week 11, but maybe I'm wrong. Forgive me if I'm language is sometimes hard for me. Okay, so let's see how we can do that. 3 and 5 makes 8. Okay, and then half and half make a whole. And 8 and 3 is 11, plus 1 whole is 12. So we have 20 pounds. So looks like 20 pounds. So how many pounds did tomato plant produce week 7 to from week 7 until from week 7 to week 11, plant produced 20 pounds of tomatoes. Okay, I will mention this, that not include week 11. All right, just in any case that I made mistake on it, but still it was a good practice. Okay, that was a B. That should also and this is how we look in our calculation. Okay, let's see if I did correctly. This 5 plus 5, 10, 15. Remember 1 and 2 and 3, 5. 5 and 3, 8. 8 and 5, 13. 13 and 8, 21. 21 and 9 is 30, and that 39. 9, I remember 3. So I think I did correct. So that would be I just double check. All right. So here you go. Another way of thinking. Let's move to the next one. Next question is C. I have another paper. I can use that one, and I can have my data, my graph on here if I needed to look the graph. All right. So which 1 week period shows the greatest change in tomatoes production? The least. Explain. How do you know? So what was the greatest production and what was the least production? The greatest is the grande and the least is chiquito. All right, so let's look our graph. We can put the greatest and the least. And then we can have our number there, right? So if we looked back to our graph, the greatest reduction was from 5 to 8. So that would be like from 9 to 10. That's 3.5 pound more in from 9 week to 10 this week. It's 3.5 pound, and then the smallest was just I think 0. You can see here that there is no growth, but it's depend on it. Do they ask growth or they ask which production was? Which week period shows the greatest change in tomato production? The least, the least explain how do you know? So the least change. If you think about this is the deepest. So that means this is the greatest change. It was from 8 to 8.5 pounds, which 3.5 grades. So that is the week from 9 to 10 weeks. From 9 to 10, that was production grew 3.5 pounds. Okay, and if you think least should be a 0, because from this week production did not change. Production stayed 0. So from week to 10, 11 to 12, from 11 to 12, production didn't grow. Didn't change. Didn't change. If you look, what is the least growth? The least growth was 0.5 pound. So then we can also include that. If you think about just the growth, 0.5 pound was here, and there is one more place, this one here. So in 2 places, there was only 0.5 pound growth from one week to another. So that's also, if you look, this is no growth at all. That's the least. And then after that, you have 0.5 pound growth here and 0.5 pound growth here. So that would be the, okay. During, that was C. Now, during week 6 and 8, Jackson fed the tomato plant just water. During week, so 6 and 8, he was just watering. And then during weeks 8 to 9, 8 to 10, he used a mixture of water and fertilizing A. And then weeks 10 to 13, he uses water and fertilizing B on the tomato plant. Compare the tomato production for these periods of the time. So 6 to 8, let's see if we can use the graph to help us. So 6 to 8, 6, okay, 6, 7, 6, 7 to 8, he did only water. So that's the water. Okay, so we only have a growth that is from 1.5 pounds to 3.5 pounds. Okay, then if we take the purple to do the fertilizer A, so from fertilizer was from A and water was 8 to 10. So it was from 8 to 9 and 10. So here is the growth. We can see that this was from 2.5 to 1, it's 1.5. So here is 5 5 pounds growth. Okay. And then when he uses 10 to 13 would be that he uses fertilizer B. So it's from 10, 12, and 13. That was, so these purple was actually looks like a brown because I have orange and also we'll do that. So this was A, fertilize A, and then this was fertilizer B. Okay, so now we can look. So if we think about growth, the most growth happened when he started using fertilizer A, and he grew, and then he started using fertilizer B. It still was it's this the growth was high, the amount of pounds, but it still was not much growth. All right, it's just stable. Okay, so during week, so what the question they have? Compare the two production for these periods of time. Okay, so we can say that the most growth happened when he started using fertilizer A. Okay, 5 points difference. So from 3.5 to 8.5, that's a 5 pounds growth. Okay, so let's talk about number 2. Use the story content below to sketch line graph that answer the questions that follow. The number of 5th grade students attending Magnolia School has changed over time. The school opened 2006 with 156 students in the 5th grade. The student population grew the same amount each year before reaching its largest class of 2010 students in 2008. The following year, Magnolias lost 1/7 of the 5th graders. In 2010, the enrollment dropped to 154 students and remained constant till 2011. For the next 2 years, the enrollment grew by 7 students each year. So that's lots of information. So we're gonna go back and start one at a time, and I am going to get this graph. So let's have this So this is our x-axis, and our y-axis we have years. Okay, so 06 represent 2006, 2007, 2008, 2009, 10, 11, 12, 13. Okay, and then the sorry, y-axis represent number of students. So they started with 150. So if this is a 0, then 150. But then they skip kind of, so we can think what the scale they have from 150 to 200. We can see that difference in between 200 and 150 is 50. So I'm going to go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 spaces. So that means in 50 points, I needed to count each unit 5. So from 0, they kind of, you can usually put the zigzag. That means this is a shortened line, and then this will be 155, 160, 165, 170, 175, 180, 185, 190, 195, 200, and then 205, 210, 215. Okay, so far these are the number of students, and then this represents the year. So the story says the Magnolian School has changed over time. The school opened in 2006, and it started with 156 students. So if this is 155, so if this is 4 lines here, 1, 2, 3, 4, this right here is going to be 156. Then after that, they say, oh, sorry, okay, they say that the student population grew the same amount in each year before reaching its largest class of 2010 students in 2008. So now we know that in 2008 there were 210 students. So go up there to find 210. So 210, it's right here. So now we need to figure it out. How much did they grow each from 2006 to 2007, and then 2008 they reach to 210 students. So how we can, and they say the growth they was grew the same amount. So we need to find the difference in between this 2010 and the beginning of the school opening was 156. So when I subtract, I will see what the growth is for those 2 years. So subtraction, I cannot give you 6 if I have a 0, so I'm gonna regroup the 10 and make 10 ones. 10 ones minus 6 ones is 4 ones. I cannot give you 5 tens if I have 0 tens. So I'm going to regroup the 100 and make that 10 tens. Now I was having 10, give away 6. Now 10, give away 5 is 5. and 100 minus 100 is 0. So 54 students was growth from 2006, 2007 to 2008, so in 2 years. So now I need to divide that, so I can do this like a bond if I want to divide into 2. So half of 50 is 25, and half of 4 is 2. So now I know that each year the population grow 27 students. So now I need to go back and add 27 to 156. So 2006 was 156. And when I add 27 students, that will be 6, 7, and 6, and 3 makes 10, and 3 left, so that is 13. I will have one extra 10, so that will 6, 7, 8, 183 students were in 2007. So let's go and find where 183 is. So 2007, 180. So now if I make increments from, I need 4 lines. 1, 2, 3, 4. That means 81, 82, 83. It's right here. So about right here. So here was 183 students. We also can check, does that matches, because when we add here 83, 183 and 27, we should get 2010, which is the number that we really got. Okay, so 3 and 7 makes 10. 0, I remember 1. 8 and 2 is 10, plus 1 is 11, and I made one more 100, so 210. So now I proved that we are in the right track about that. So that's next. Let's read the next clue. So we did this. We start with 156. Then next 2 years they grow the same amount, 27 students, and 2008 it was 2010 students. Now the following year, Magnolian lost 1/7 of 5th grade students, 1/7 of this 210. So so 2000, the following year, that means 2009, it was 1/7 of 1/7 of 210. Okay, we need to find what is 1/7 of 210. Then we will know how many students they lost. What this means is 210 divided by 7. If you like, you can think about this to be 21 times 10. So 21 divided by 7 is 3, and times 10 is 30. So they lost 30 students. I don't know, do you make that understanding how I did this division? If you think about 21 tenths, so you got 21 tenths divided, and this is good idea, 21 tenths divided into 7. You can say 21 divided into 7 equals 3, but what? 3 tenths. So 3 tenths is 30. And that's another way of thinking. So 30 students less they had in 2009. So right now we needed to subtract 2010 minus 30. So if you think about this, you can think about 200 minus 30, that's 170 plus 10 is 180. But if you do standard algorithm, that would be that this is 11. So 11 minus 3 is 8 and 180 students. So we know that in 2009, they had 180 students. Okay, now we're going to graph that to our point. 2009 is right here, and we're looking for 180. So drop down to 180. So it's kind of like going grow. So if I connect the dots, it grows, and then again it grow, and then it's drop down to 180. So now we need another clue. Then that is in our story. The following year, Mongolia lost 1/7 of fifth graders. We figured it out that. In 2010, the enrollment dropped to 154 students. So from 180 in 2009 into 2010 dropped to 154. Okay, so let's a little bit, and remained constant in the 2011. So when they say if they drop to 154, then remained 2010 and 2011, they both year they have 154 students. So right now, from there, we need to go to 154. So 150, okay, 55. So if I go 1, 2, 3, 4, here is 154. It's about right here. So 2009 is right here. So the point is right there. Okay. So here is 154. So that it drops to 1054 in 2010, and then it stays 154 to next year as well, 2011. So here is the same, so that didn't change. And then we need to read the last clue. For the next 2 years, the enrollment grew by 7 students each year. So this is important. 7 students each year for the next 2 years. So if we go that, it was 154 here, and then 154 plus 7. This would be a 7 and 4 is 11. Remember 661. So now it grew to 161, and 161 is about here. Okay, 1, 2, 3, 4. Okay, 161 is about right there. So 2012 is right here. Okay, and then again, next year grew 7 more, so 168 would be the year 2013. So 165, 66, 67, 68, 69, 70. Okay, so 168 is about here. All right, so there you go. There you go. Okay. So okay, this is the best I could create. So this was so between which and that is the graph of how the number of students changed through years at Mongolia school. Let's see, answer question B. Between which two consecutive years was there the greatest change in the student population? Consecutive means next to each other. So, which two years the change was the greatest change? So, the greatest change in the student population. So, if you look our graph from beginning to here was a changed, but it looks like the change from 2010 to sorry 2008 to 2010 was the most drastic. It was greater than this growth. The so from 2008 to 2000 2000 from 2008 to 2009. Okay, and then 2010. So from 2008 to 9, so 2009 and 2010. 2009 and 2010. This is the most drastic change. 2009 to 2010. Okay. 2009 to 2010 was the most change. You can see it was from 210 210 goes back to the 154. So we can calculate 210 minus 54. So that's 111. We'll take that as to be 10, 6. So 56 students difference in between those two those 2 years. All right. Let's talk about next question. If the 5th grade population continued to grow the same pattern as in 2012 and 13, in what year will the number of students match 2008 enrollment? So, pattern was 7 years each. So it was 168 students right here. And then 2008 was 2010. So if we subtract this 168 from 2010, we will see how many, what is difference in between. And then we'll know if you divide by 7 into groups of 7, we will figure out how many years will take to go back up to the same point that is right here. So let's see that. So 2010 minus 168. So if we, okay, sorry, standard. So I have to regroup. 10 minus 8 is 2. Again, I can do this. 10 minus 6 is 4. And 42 students difference. So now we know if we divide 42 in groups of 7, we will have what number time 7 equals 42. So 6. It will take 6 years to go back to the 2008 enrollment. Okay, it will take 6 years to get the same enrollment as in 2008. As in 2008. Okay, that was a long thing. So I hope that you understand some of it. It was, I'm going to make it smaller. So we did lots of work. Oh, sorry, no, smaller. Okay, so we start with this problem set. Okay, and then problem set number 1, A, B, and then we had finish C, D, and then we start problem 2, which was that school Mongolian. There's information for that, and then we drew the graph and answer A, B, and C questions on that problem. All right. So thank you for listening. Appreciate you. All the best. Bye.